Welcome to our lesson on inscribed angles. So let's start with some definitions. An inscribed angle is an angle whose vertex is on the circle, and the intercepted arc is the arc that lies within the interior of an inscribed angle, where the endpoints of the arc are the intersection of the sides of the angle and the circle. So if we look at it visually, the inscribed angle is the green angle here. Notice the vertex is on the side of the circle. The intercepted arc is the piece of the circle that is inside that angle, or in between the two sides, here in this reddish-orange color. And there are some theorems that go with this. They're very much related, but technically they're two separate ones. The measure of an inscribed angle is 1/2 the measure of its intercepted arc. So the angle in green is half the measure of the arc in red. And the same is true if you are using a tangent in a chord. So the red angle 1 is half the measure of the arc in red. And the green angle 2 on the left of that diagram is half the measure of that entire green arc. That's a lot to remember. Let's put it simply. When the vertex of an angle is on the circle, 2 times the angle equals the arc, or you could say that the angle equals 1/2 the arc. Let's look at some examples. Here we want to find the measure of angle T. So here is angle T, and we need to find the intercepted arc. That would be this here. So we know twice the angle equals the arc. So 2 times angle T equals my arc, which is 48. Divide each side by 2. So angle T equals 24 degrees. The second part of this problem wants us to find the measure of arc QR. So arc QR is this blue arc here. We don't have an angle that intercepts it, but we do have something very important in this diagram. TR is a diameter. It goes side to side of the circle and through the center. A diameter will always create a measure of 180 degrees because it's a semicircle. So all the way around here, that's 180 degrees. And that leaves me with the arc TQ. And that's the green arc. When I look at these different pieces, the full semicircle is 180, and that equals my blue plus my green arcs. So I need to find one of these. Well, I notice that my green arc has an angle that intercepts it. Let's erase some of this extra stuff. Here's the green angle that intercepts my green arc. So TQ, that arc, equals twice my angle, 50. So arc TQ equals 100 degrees. So what I'm going to go do is plug in 100 over here to the left where we have the blue plus the green. So now I'm able to find QR, which is, remember, what we're trying to find is that blue arc. Because I could call this X. And now I have 180 plus X plus 100. So I'll subtract 100 from each side. And I find that 80 equals X, which is the measure of arc QR. So that was a really key thing to notice. You've got to look for your diameters in these problems because that's going to break your circle down into smaller pieces. That's usually very, very helpful. Here's a slightly more simple problem, but it looks very different. Okay? It looks different because we have a tangent here on the outside, but it's the same process. Here is my angle 1, which means my intercepted arc is all of this out here, which is 260 degrees. So we know that 2 times the angle equals my arc. 2 times my angle, and my arc is 260 degrees. Divide each one by 2. My angle is 130 degrees. Okay, you guys try this one out. Give yourself a moment, hit pause if you need to. Find the measure of arc RST. So this green arc here. Find that measure. Go ahead. Okay, so the arc is twice the angle. 98 times 2 is 196 degrees. Great job, guys. Keep it up. All right, let's move into something with some algebra and solving. So here we have this circle, and we have a variable x inside of my inscribed angle. When I look at my inscribed angle here, I notice that I am missing any information about this arc. So I have to go find some info. What I do notice, though, is that this blue arc here, 103, plus this red arc, when I add that to my green arc, that's going to give me an entire circle. Notice the whole circle is colored in. So those 3 arcs combined give me 360 degrees, the whole circle. Well, now I can go ahead and solve for my arc. Let's just call this A so we have a variable in here. 103 and 107, that's 210. Plus A equals 360. Subtract 210. So A equals 150 degrees. So that's the measure of my green arc. Now we can focus just on my inscribed angle. Our angle, remember, 2 times the angle equals my arc. I'm going to go ahead and plug in the algebraic expression for the angle and the measure for the arc. My angle is 7x minus 9, and my arc is 150 degrees. Distribute your 2. 14x minus 18 equals 150. Add 18 to each side, and then divide by 14. And we have x equals 12. So we had to look for the different pieces that made up the whole circle in this problem to get us to our answer we needed. All right, let's explore another theorem here. Find the measure of arc RS. Here's arc RS here in green. And we want his measure. That means we're going to need an inscribed angle. Here's an inscribed angle. He has a measure of 31 degrees. So 2 times my angle equals my arc. 2 times 31 equals 62. So the measure of my arc, RS, is 62 degrees. The next part wants us to find the measure of angle STR. So here's STR. That angle intercepts the arc SR. So again, 2 times my angle equals my arc. We want to know the angle measure, and we know the arc is 62 degrees. Divide each one by 2, and the angle is 31 degrees. So this actually shows us a theorem about inscribed angles in their intercepted arcs. So if you have 2 inscribed angles of a circle that intercept the same arc, the angles are congruent. So here on this circle, I have an inscribed angle. I can move the vertex of this angle anywhere on this circle, and I will not change the measure of the angle. That is because these 2 points here where the angle intersects the circle are fixed. So I'm not changing that arc measure. I'm just moving the vertex. Because the arc is not changing, the angle also is not changing. Kind of a fun little fact. We have one more theorem to look at. So here we have, if a right triangle is inscribed a circle, that only happens when the hypotenuse is the diameter of a circle. So here we would have a right triangle. That's only going to occur when we have a diameter on your hypotenuse. Why? Well, if I trace out this angle, we know that a right angle is 90 degrees. We also know that 2 times my angle equals my arc. So 2 times 90 equals 180. So this arc out here is 180 degrees, but 180 degrees is half of the circle. And half of a circle is only created by having that diameter, which means AC would have to be a diameter. Dividing my circle in half. So let's look at a problem that involves this. Find the measure of each of the following. Let me start you off with this. Some of the easiest ways to approach these problems, fill in what you know. Don't look at what it's asking, just fill in the information you know. So I see this inscribed angle here. That's 31 degrees. So if I double that, it means that I have a measure of 62 degrees for this arc out here. I also notice I have a diameter. I know that x is z is a diameter because it goes side to side and it's going through the center. It's going through that pinpoint center right there. Diameters divide the circle in half. So this left side is 180 degrees. And then I can find this last arc up here towards the top right, xy. So xy is the last missing piece. If I take 62 and add it to 180 plus this unknown xy arc, that gives me a full circle of 360. There's 3 arcs that make up this whole circle, and I have them represented. 180 plus 62 is 242 plus y equals 360. Subtract 242, which means y equals 118. So I'm going to fill that in on my diagram. And then I'm also going to go ahead and find my angle measures. So angle y is intercepting that semicircle of 180 degrees. We just talked about this, right? If I have a semicircle of 180 and I take half of that to find my angle, that means I have 90 degrees. 2 times the angle equals the arc. So 2 times my angle is 180. And when I divide each of those by 2, I find my angle equals 90 degrees. And then you can do the same thing for angle Z, or you can use the triangle sum theorem and look at just that triangle. So if I use triangle sum theorem to find angle Z, 180 equals 31 plus 90 plus Z. Subtract it all from 180, and Z equals 59 degrees. Now you have everything filled in. Go back and fill in what it wants to know. YZ, arc YZ, we have 62 degrees. Arc YXZ. YXZ starts at Y, comes around to X, and then goes to Z. So YXZ, we have to add the 2 arcs that we cross, 118 and 180. 298. And then the measure of arc XY, 118. And the measure of angle ZYX. ZYX is our 90 degree angle. Again, just look at the individual pieces, find those first, and then focus on filling in the answers and finding what you don't know. So let's just wrap up a few things to remember. Inscribed angles have the vertex on the circle. Also, 2 times the angle equals the arc, or you could say that the angle equals 1/2 the arc. Don't forget, when you're doing these problems, look for the individual pieces that make up a whole circle, because a circle is going to equal 360 degrees. And you want to look for diameters. That should be on here as well. Look for diameters because that's going to give you 180 degrees. Other than that, that's all for this lesson on inscribed angles.